Alright, welcome back to another homework video, guys. Today we're working on homework 3 from semester 2. And this homework had you guys working with the concept of check digits, which, as it says, can be used to help detect if an error has occurred when a number is entered or transmitted electronically. So you guys are only responsible for 2 methods of the check digit class, and you had get check and is valid, and you were given a couple helper methods, which were get number of digits and get digit. Yep. So this is pretty common when you're given helper digits and you're not actually told how they work, or the lines of code. And so if I actually tried to run this here, and probably if you tried to run yours, it wouldn't do anything because you had these methods that you were supposed to use and hopefully that you used, but you don't actually have code for, because you weren't responsible for them. So the AP scores will expect you to use these. So even if you, where I call this, if you wrote all the code that these had, which would accomplish the same thing, instead of just using the method, which would be reinventing the wheel, so to speak, then you won't get full credit if you just went ahead and used the method that they gave you. So let's go ahead and jump right in. So first method you guys are responsible for was get check, with parameter int num. And then so we have int a equals 0, b is 7, c is 0, and then we have this interarray r, which is the length is get number of digits. So however many digits are in num, that's how many indexes are going to be in this array. And so I kind of talked about this last week, but the way that you guys call methods within classes that's like the classes where it's being declared, you don't have to do check digit dot, you don't have to do num dot, you just do get num digits with the parameter, and Java will know what you're talking about as long as the method is declared in that class. And then so we have this while loop while a is less than get number of digits, r of a equals get digit num of a plus 1. And so what I'm saying here is that, so the first time through, right, we have a is 0 because we want to start with the beginning of the array. So r of 0, so the first index of get digit num, so like our number here, and then we want to start with the first digit because you can't really have a 0th digit of a number, so the a plus 1 is needed here, so it's 0 plus 1, and then the next time we go through it's 1 plus 1, so it's the second digit, so on and so forth. And then times b, because our definition for a check digit was you multiply the first digit times 7, second digit times 6, third times 5th, so on and so forth until you run out of digits. And so that's how that works. And then after that, we're going to do b minus minus. Remember, that's the same thing as plus plus. We're just subtracting 1 from b, so b goes to 6, and we're adding 1 to a. We keep doing that until we reach the number of digits, and then we go ahead and stop. Because then, if we do it one more time, we'll be pushing this out of the number of digits, and that won't work. That'll probably give us an error in this method here. And then, so once we have all of our products, we have this for loop, int d equals 0, d is less than r dot length, and I could have used r dot length up here, I just went ahead and chose not to. They're the same thing since we have this length declared as get number of digits, then we're going to continually add 1 to d. And then this is a notation maybe you guys haven't seen before, maybe you have, plus equals, and it's the exact same thing as writing c equals c plus r of d. So I know you've seen that before. We're adding r of d to c over and over again because we want to add all those products together. And so plus equals is just an easier way to write that. You can also have times equals, you can have divide equals, you can have minus equals, and it just means continually subtracting, adding, dividing from, like, changing this variable. So once we've added all those together, we're going to do int e equals c modulo 10. And so if you remember, the modulo operator, what that does is it returns the remainder when you divide a number. And so the cool thing is if you do modulo 10, like we talked about, modulo 2 tells you whether or not it's an even or an odd number, right? And then modulo 10 will always give you the last digit. So let's think about 329, right? So 320 goes into 10 evenly, and then you're left with a remainder of 9, so it will give you 9. And then if you did 325, same thing. So this always gives you the last digit, and then even if it's just 320, you get 0 because there's no remainder, and so that's what we wanted anyway. So modulo 10 always gives you the last digit, so that's just a helpful thing to know in general. And then because we want the last digit of our summation, we go ahead and return e. And then the second method you guys are responsible for was is valid, and that was for just another int parameter. So we start with int last equals num with check digit modulo 10. So again, we're taking the last digit of num with check digit. And then we have int check equals, so we're going to get the check digit of num with check digit minus last, because we don't want to get the check digit of, like, so if the example they give you was 159, right? Go down here, hold on. Yeah, so 159. So the check digit of 159, we don't want to find for our parameters 1592, which we want to return true because that's a valid combination of 159 and it's check digit 2. So we don't want to find the check digit of 1592. However, you might be thinking, well, if we subtract 2 from 1592, we just have 1590. Well, that's the interesting part. So we go ahead, and the way that check digits are found, remember, is we multiply the first times 7, second times 6, third times 5. So this ends up giving you, once you add it all up, 82, which returns 2. So if we do the same thing here, first times 7, times 6, times 5, this times 3, but that doesn't matter because anything times 0, right? Because we subtracted 2 from this, so it's 1590 is 0. So then we don't add anything from there, and we still end up with 82, and we still end up with a check digit of 2. So by subtracting num with check digit minus its last digit, we make that last digit a 0, and so it doesn't matter anymore. And because no matter how many digits are in your number, you always start by multiplying by 7, so it's not like you go up based on how many digits there are. You always start with 7. That doesn't matter. So that's why we're allowed to do this. So yeah, in essence, what I'm saying is that the check digit for 1590 or 15900 is the same as 159. Because of the fact that the 0 multiplier ends up being 0, so when you add it all together, it doesn't change anything. So hopefully that makes sense. And then, so we get the check digit of whatever the first couple digits are, and then we compare them, right? Because we want to see if the last digit of our parameter is the same as the check digit of the number that we're looking at, right? So like I said, 1592, we want to return true because it's a valid combination of 159 and its check digit 2. So if last, which is our last digit of the parameter, and check, which is the check digit minus the last digit there, are the same, then we want to return true. Otherwise, we want to return false. And I did this a lot when I was in AP, but I always like to do this because especially first quarter, Dr. Neat teaches you to do this if you have an if statement to have an else statement. The one problem is that Java has trouble with this. It doesn't like there being only return statements inside of Booleans, like stuff that, So even though this will fire for sure, like one of these will fire for sure, Java doesn't like it. So I always just leave that out, and it doesn't matter anyway, because if this returns true, it doesn't get to this line of code. And then if this doesn't return true, obviously we want it to return false. So that's why I left out the else there. Hopefully that all makes sense. Hopefully this helped you guys. As always, feel free to drop any questions down in the comments, and I'll see you next week. Thank you.